Okay, let us start because I think very few have joined, but let it be. I don't have sufficient time to complete. So anyway, as I have declared that we'll be doing now, the next two transforms are remaining, which are for the analog system, and that is Laplace and the Fourier transform. So in this week, I will be giving you the Laplace transform, basic definition, standard functions, what is the answer output as such system, and same thing in the next week for the Fourier transform we will be doing. Okay, so I'll be sharing my screen. So just the definition and the basic preliminary part for the Laplace transform, I will be showing it here through the PDF, and then on my pad I'll be solving the examples, okay, which will be easy for you to understand. And of course, again and again I'm telling the same thing. Whenever the session is over, that if you can practice some problems, it will be easy. And requesting all to mute yourself. Sharada Patil, please mute yourself. Sharada madam, please mute yourself. Yes. So I think the screen is visible to all of you.
Yes, ma'am.
Good. And this is what the basic lecture where I have started with the transforms, in which already I have told you for the analog system, we will have to, means we are going to learn this Laplace and the Fourier transform. Of course, it is not at all new for you, because in your graduation studies, you might have learned that is a Laplace and Fourier transforms. So same thing we will be doing here. And in the digital system, the Z transformation. So Z transform was a little bit new for few students, few branches students, because for computers as well as for ECE background students, they might have learned this thing, but the rest of the students, like from mechanical, civil, they will not have that Z transformation earlier. So this was a new part for them. But these two, Laplace and Fourier, I think it is there for all the branches in the UG level. And most of you might have learned. Of course, again, I'm not expecting that everything you will remember, and lot of formulae are there, because every transformation is nothing but it is a formula based. So what formulae we have, accordingly we will get the output of the system. So our main purpose of learning these transforms, in the initial lecture I told you that to solve the differential equations in the areas of electrical circuit, beams and string problems, where you have studied, because depending upon your branch, you know how to use the transformation. Okay, so mainly to solve the differential equations. Okay, ordinary differential equations we are converting into the algebraic equation, and then the transformation, because solving algebraic equation is much easier than the differential equation. So converting the differential equation into the algebraic form and then get its a solution with the help of this transforms. Okay. And as you have seen in the Z transformation, we have used the difference equation. Okay, that is the only difference in the discrete system. So let us see what is the definition of the Laplace transform. First of all, Laplace is of course the name of the scientist, Joseph Laplace, and who invented the function, which is a time domain function, converting into the frequency domain. And how it is converting, so that is happening with the help of the integral, which is of the form 0 to infinity limits e raised to minus st f of t dt. Strictly you have to put the exponential term in the negative power, then only the integral will be valid, or integral will give you the value, finite value. Otherwise it will be an improper integral. So this is a particular integral definition. 0 to infinity limits a standard. One of the function is exponential e raised to minus st, and another function is f of t, means time function, okay, time domain function. And the resulting expression, when you simplify, put the limits for t and everything, that answer is remaining in the form of s, and that s is here actually the parameter which is the frequency domain. So your time domain, you are shifting it to the frequency domain. That is the main purpose of using the transformation. So S is the parameter which can be real or the complex number in this process. Okay, so this is just to give you the information. So this is written, that is an existence condition. So question arises whether Laplace transform is possible for all the functions. All the functions means can be algebraic, can be logarithmic, can be inverse, can be trigonometric, and like that. So many functions you have learned. So our question is whether Laplace transform exists for all. So for that, the answer is of course no. Okay, all the functions are not going to give you the Laplace transformation. Then what is the condition? Which functions are giving the Laplace transform? And for that, this is a sufficient condition explained by this Laplace. That is, if f of t is a piecewise continuous in every finite interval. Piecewise continuous means partwise continuous. Okay, so after some part again it is a discontinuous, then in the next part it is a continuous. So it's like this. This is the graph of the piecewise continuous function. Piecewise continuous in every finite interval in the range t greater than or equal to 0. So only the positive part of this t, and is of exponential order alpha, then its a Laplace transform exists. What is the exponential order alpha? For that we are using this definition. Exponential order का मतलब है when alpha, m and n are constants, then modulus of f of t, means absolute value of the function, is less than m into e raised to alpha t. That is the condition. So the value of the function f of t modulus का मतलब है absolute value, which is always less than some number multiplied by e raised to alpha t. Then that alpha becomes the exponential order here. So for all t greater than n is some number here chosen. Okay, or the definition is given like this: if e raised to minus alpha t into f of t remains bounded. So अगर आप ये यहाँ पे shift करोगे तो यहाँ आएगा, and this will give you e raised to minus alpha t. Okay, e raised to minus alpha t mod f of t less than m. मतलब m is some number. The term e raised to minus alpha t into mod f of t remains bounded as t tending to infinity, because e raised to minus infinity is giving you the answer as a 0. And then in that case f of t becomes the exponential order alpha. Okay, so these are the two conditions. That is, function should be the piecewise continuous function in every finite interval and is of exponential order alpha. Then only the Laplace transform exists for the function of t. Okay, so like here, this is a piecewise continuous expression. T, this is given t naught to this t3, t1, t2, t3, and t4 up to this. The values are given on the t-axis. And how it is defined in a to t1. पहला जो interval है a to t1, this is your a, and this is actually b. A to t1 में the function is defined as f1t, which is giving this graph. Then t1 to t2, the function is f2t. So this is the graph, second function. Then t2 to t3, this is a new graph. And t3 to b, the last one, this is a graph. Like that. So in different parts, the function is a continuous, giving continuous graph. So that is why it is called as a piecewise continuous. So these two conditions, when it is fulfilling, then only we can find out it's a Laplace transformation. Okay. So now certainly whatever the functions we are going to study, they are giving you the Laplace transform. That is why we are learning only those functions. So in your studies, you are not going to get the question where it is asked that identify whether Laplace transform exists or not. That is none of your business. Only thing is f of t function is defined to you, which is giving you the Laplace transform, and you are only interested in what is the answer of that Laplace transform. Okay, so those functions only we are going to learn, which are giving you the transformation by satisfying the condition, which is a piecewise continuous and the exponential order. Okay, this is actually the theoretical mathematical part where students from pure mathematics have to learn all these things. Your aim is in your branch, if you get some function f of t, then how can be applied Laplace transform and get its answer as an outcome. Okay. And therefore, this note you can have the existence condition is only sufficient, means even the function is not piecewise or exponential order, the Laplace transform may exist. I hope all of you know necessary and sufficient. These are the two parts of any theorem. Necessary and sufficient means to and fro way. Okay, so if the function is piecewise and exponential order, then certainly its Laplace transformation may exist. And other way, the condition is sufficient, means if Laplace transform exists, then the function should be piecewise continuous and is of exponential order. That is what we can understand. Okay, so like examples are quoted, 1 upon root t, which is not a continuous at t is equal to 0. Because t is equal to 0, if you put it, the answer is infinite. So certainly at t equal to 0, this is not a continuous function. But 1 upon root t will give you the Laplace transformation. Okay, but Laplace transform exists for 1 upon root t. How? That we will see in the actual definition. So we will be doing now standard functions. So I'll just show you one or two expressions, and then the list of formulae you can have. Same PDF will be uploaded in the, already it is there, I think, in the Google Classroom. You can see, you can access that anytime. But how the answer is coming with the help of process is of course the integration. So all integration ke basic function ke answers plus methods of integrations like substitution method, integration by parts procedure, integration by partial fractions. All these methods we will be of course using. And initially only I told you, compared to your z transformation, these continuous function के transformation थोड़ा difficult है क्योंकि यहाँ पे integration करना पड़ रहा है. Whereas in z transformation we have not done anywhere integration, that was just a summation, and we were checking whether the series is a convergent for the range which is given. Okay, but here in this case we have to solve that integral and get the answer of the integration. That will be our transformation. Okay, so I'll just show you how the transformation integral will give you the answer for that. So let us take so by definition, f of t is a function of t, then Laplace transform of f of t is equal to integral 0 to infinity e raised to minus st into f of t dt. Okay, t greater than or equal to 0. That is the condition. So very first we will take some constant k. Okay, so if f of t is a constant function, like k is a constant. Okay, if I choose this k, then what happens? Then we'll see Laplace transform of k. That means integral 0 to infinity e raised to minus st term as it is. F of t is replaced by k. Integrate with respect to t. Now, as k is a constant, we can keep it outside the integral. and we can do only the integration of e raised to minus st term with respect to t. Correct? And you know what is the exponential function integration? What is e raised to ax integral part? What is the integration of e raised to ax? इंटीग्रेशन ऑफ e raised to ax क्या है?
E raised to ax upon a.
E raised to ax upon a. Very good. Sorry, a. So whatever the constant multiplied with x, that will come in the denominator. Integration is exactly the reverse process of differentiation. So if you know the differentiation of e raised to ax, usko ulta karna hai, then you are getting the answer for the integral. So in this case, this a is here with negative sign s minus s. This will be our part of a. Okay, and variable is immaterial in the definite integral. You can use t, you can use u, you can use v, anything. So k will be outside and integral will be e raised to minus st upon minus s in the limits 0 to infinity. Correct? And when you put the upper limit, you know definite integral, how it can be solved. Pehle upper limit dal do, that is infinity in place of t, and minus the lower limit. So e raised to minus s into infinity upon minus s minus e raised to minus s into 0 upon minus s. I'm just writing all the steps because might have forgotten the integration procedure. So this is a basic integration which we are doing. And here, this is important. E raised to minus infinity will be always equivalent to 0. Or this is the same thing as in the limiting form. Limit t tending to infinity, e raised to minus t will be giving you the answer as 0. That can be used here for the upper limit. So k will be here outside as it is. Pehla term 0 minus e raised to 0 is 1 upon minus s. So your answer comes out as k upon s. Followed? So Laplace transform of k is k upon s. That you can remember as a formula. How the formula is coming? That is because of the definition. E raised to minus st into f of t. For example, suppose if I want Laplace transform of half, what is the answer? What do you write the answer directly?
Half upon s.
Yes, so that is 1 by 2s, correct? Similarly, Laplace transform of 3, that is 3 upon s, and etc. So any constant. So in general, therefore, Laplace transform 1 will be 1 upon s. Got it? This is the very basic first expression where the transform answer is 1 upon s for 1, and for k in general we are getting k upon s. Okay, and one more I'll show you Laplace transform. So if f of t is equal to, say, suppose exponential term e raised to at, then Laplace transform of e raised to at nikalna hai. So again, by definition, this is integral 0 to infinity e raised to minus st into e raised to at dt. So I'm just putting f of t answer as e raised to at. Now club the exponential powers in the integral sign. So 0 to infinity e raised to, I can write down this as minus s minus a into t. Am I right? Yes, are you with me? Is this correct?
Yes, madam.
You're writing e
Yes,
raised to
madam.
minus. Now every time please see carefully. I'm taking the negative power of the exponential term. Okay. नेगेटिव पावर इंडेक्स में होनी ही चाहिए, मतलब दिस पावर strictly it should be negative, then only you can integrate it, and integration is giving you the value. And just like in the previous case, e raised to ax ka integration is this one. So here what you can write, what is the integration? What will be integration? E raised to
Uh,
upon minus of s minus a. Whatever is multiplied with t, that will be divided in the integration. And the limits are 0 to infinity.
Hello, ma'am.
Ah, yes.
Here first term was like e raised to Laplace transform of e raised to at is equal to 0 to infinity e raised to minus st into e raised to ad. That is e raised to at is our k, right? Uh,
No. You combine them together. T is common.
no,
Huh.
e raised to minus st dt. It is there, right? It is the constant term, and e raised to at is in the place of k. Like if
No,
it is Laplace.
madam. No, madam. Please
No.
see. E raised to minus st is not at all constant. It is containing t, no?
Okay.
That's not constant.
Yes.
It's
Yeah.
an
Yeah.
exponential function. And in the previous example, that k was constant. But in this case, this e
Okay.
raised to at is another function of t. And
Okay.
since your standard function, standard definition में जो function है, that is always there, e raised to minus st, which is
ST.
also
Yes.
exponential. So we are clubbing
Okay.
these two and getting the
Okay.
index as minus s minus a.
And ma'am, I just didn't get that. In the second step, e raised to minus in bracket s minus a into t. How that term came?
I have just clubbed no this thing. In the both are exponential functions. So indices का
Okay.
addition होता है whenever it is
Yeah. Yeah.
multiplied.
Yeah.
Huh? So actually you are
Okay.
having
Okay.
minus st plus at, and that is
Yes.
written as minus taken outside. So it's minus a into t. Hmm?
Okay. Okay.
This is addition of the
Thank you, ma'am.
indices, and so we'll get
Yeah.
this.
Yeah. Yes,
Now
ma'am.
when you
Yeah.
put the upper limit infinity, you will be getting what you will be getting upper limit infinity के लिए. So you will be getting minus infinity, e raised to minus infinity upon minus s minus a minus lower limit ka negative sign, and e raised to minus of 0 upon minus s minus a. And once again, e raised to 0 is 1, e raised to minus infinity is 0. So your answer will come out as minus of minus plus 1 upon s minus a. Followed?
Yes, madam.
So answer for Laplace transform of e raised to at will become 1 upon s minus a. And provided this s here in the expression should be greater than a. Otherwise, this power will become positive, and which is not at all possible to get the integration if the power of the exponential term becomes positive. So strictly we want the power of exponential term negative, and for that we should have the condition s should be greater than a. This is the condition. S is a parameter, a is a constant. So accordingly, for example, if I want to calculate Laplace transform of e raised to 3t, what will be the answer? What is the answer for this? 1 upon s minus a. So
1
what
1
will
divided by
Minus
s minus
3.
3.
1 upon s
S
minus
minus
3.
3.
minus 3. So that is actually function of s. So generally function of s, we write it as a f bar of s. Suppose if I want to calculate Laplace transform of say 2 raised to t. 2 raised to t. Can you convert this 2 raised to t in the exponential form? Anybody? Because we know the formula for exponential term, e raised to a t ka. So can this 2 raised to t is expressed as exponential term? Is it possible? You know logarithms. So this is known. Suppose if I put
T log
huh?
T log T log 2.
Yes, very good, very good. That's perfect. See, if e raised to t, if I put this as equal to something y, then I want the answer for t, which is calculated by log y to the base e. I hope this already you know. Everyone knows logarithm means what. So log of y to the base e is equal to t. So here also 2 raised to t, if I put it like that, 2 raised to t is equal to this expression, then can be replaced by t log 2. Okay, so 2 raised to t will be your expression for this y or x you can take, and therefore 2 raised to t becomes t into log 2 or log 2 into t. So log 2 is nothing but your constant term, e raised to, of course. Sorry, I have not written. 1 minute. Yes. So this is actually e raised to
Is to T
t
log
log.
2.
This is like e raised to t log. So your answer of a is log 2, the coefficient of t. Okay. And therefore, this is your a. So your answer will be therefore what is f of s means 1 upon s minus a. So a is log 2. So we'll be getting Laplace transform of 2 raised to t as 1 upon s minus log 2. Okay. So this is just to know the expression for 2 raised to t, 3 raised to t, 4 raised to t, anything which is calculated by this particular form. Okay. And likewise, third expression I will take it for sine and the cosine functions. Okay. So trigonometric functions. And I forgot to tell you again here, e raised to at answer is 1 upon s minus a. So certainly Laplace transform e raised to minus at will be 1 upon s plus a. This should be understood. If negative power is there for the exponential term, you will get the answer as 1 upon s plus a. So the value will come out as 1 upon s plus a. So third expression we will take it. Find the Laplace transform of if f of t is equal to sine of at, then it's a Laplace transformation. So it's Laplace of sine of at, which is calculated from again definition 0 to infinity e raised to minus st into sine of at dt into sine of at dt. Yes. So here we are using the formula for exponential function multiplied by trigonometric function result in the integration. Okay. So using formula e raised to ax sine of bx dx, which is nothing but e raised to ax upon a square plus b square into a sine of bx minus b cos of bx. Formula you can write down. This is a standard integration result. Okay, using this formula, now we will apply. So in the given expression, you have here the value for a is minus s and value for b is a. Okay, so that is to be understood. Baki variable to t hai, it doesn't make any difference. So we'll be getting the answer as e raised to minus of st as it is upon denominator a square means s square plus a square into bracket a means minus s into sine of bx, that is 80, minus a into bracket cos of b is again a, cos of 80, and in that we are putting the limits 0 to infinity. Okay, so again, once again, we can use the upper limit expression as a 0. So since e raised to minus infinity is equal to 0, so upper limit answer is 0 minus lower limit ke liye e raised to 0 upon this is s square plus a square into bracket. Now minus s into sine 0. Sine 0 is 0 minus a
FYA
minus a
सुरेश चव्हाण
0.
27 पैकी 16 पास आहे. नाही ते तुम्ही करा ना, लिहून घ्या एका ठिकाणी कुठेतरी बाजूला. 27 पैकी 16 पास, 11 फेल. ए बाबा याच्यावर लिहायचं. 16 पास.
So we'll get
Okay.
minus e raised to 0 is 1, and we will be getting the answer. Sine 0 is 0, cos 0 is 1.
59.25
Okay.
आणि 20 आहे
Pallavi Mitkari, please
25
mute
पैकी 12
yourself.
पास.
Pallavi madam, please mute yourself. Yes, and therefore we will get the answer for this. First term it is 0, minus, minus, we are getting plus. A will remain, denominator will remain as a square plus a square. And therefore, transform of this sine 80 will become a upon a square plus a square. That can be remembered as a standard result. Got it? This is a function of s. For example, Priyanka madam, please mute yourself. For example, find out this one. Find transform of sine t upon 3. What is the answer for A here? What is A? in
1
this?
by 3.
A is 1 by 3. That only we have to see in the formula. In the formula, this is 1 upon 3 upon s square plus 1 upon
Plus
3 bracket square.
1 plus 9.
Correct.
1 upon 9. Huh?
Yes. So we are getting the result as 1 by 3, 1 upon s square plus 1 upon that's our function of s. Okay. one more expression. If I take, for example, if it is asked, find the transform of, say, okay, we will take one more result for the cosine function, and then together we'll take it. Okay, in the example. So next, fourth one you can have, if f of t is equal to, say, cosine function cos of at, then what it will be, the giving you the answer for the transforms. Cos of at. So same definition, 0 to infinity e raised to minus st into cos of at dt. And here we are using this integral method. So using the standard formula for e raised to ax cos of bx plus c, or bx just it is there, which is nothing but same way, e raised to ax upon a square plus b square, and a multiplied by cos of bx plus b multiplied by sine of bx. This is the formula. So in our case, now identify what is a and what is b. So once again, this minus s is nothing but your a, and this is your b. So just replace them and write down the result. So this will become e raised to minus st upon s square plus again a square into bracket, a means minus s cos of at plus b means a into sine of at, and in the limits 0 to infinity for all. So once again, upper limit answer is 0, as e raised to minus infinity will come. So this is 0 means first term is 0, minus lower limit answer is e raised to 0 upon a square plus a square into minus s cos 0 plus a into sine 0. And this sine 0 is 0. Once again, cos 0 is 1. So we will be getting final answer. What is remaining? Just tell me. What will remain?
Yes, upon
S divided by S square plus A square.
plus a square.
This will come out as s upon s square plus a square as a function of s. And this is a transform of cos at. Okay. So I think this is sufficient to understand that how the answers in the form of s are coming when we are operating this integral term 0 to infinity on any function of t, which are satisfying the condition piecewise continuous, as well as it should be the exponential order form. Okay, so this is a transform of cosine function. So in general, for example, if I want to calculate the transform of cos of 4t, suppose, then it will be s upon s square plus 4 square is 16. So the difference between sine and cosine answer is, sine answer is coming out numerator constant a, and cosine answer mein numerator is a parameter s. Okay, so that is s upon s square plus a square, so which is equal to 4 square. So another example as such you can have, this is sine of, suppose it is asked find this transform of sine of 3t plus 2. 3t plus 2. So suppose this is the question. So sine 3t plus 2 can be written as, using the sine property, a plus b wala formula. What is sine of a plus b? Already we have used in the z transform also.
Sin A cos B plus cos A sin.
Yes. Sine a. So a is here 3t and b is 2. And therefore sine transform is sine of 3t plus 2 becomes sine 3t cos 2 plus cos 3t sin 2. Okay, now cos 2 and sin 2, these are the constant values. But sin 3t, cos 3t are the t functions. This is t function, this is t function. And therefore, when you take the transform of this sin 3t plus 2, you have to take the transform of all the terms on the right hand side. So sin of 3t cos 2 plus cos of 3t sin 2. There is a linearity property in the Laplace transform. So addition of two t functions, you can separate them and take the separate Laplace transform. So this can be written as L of sin 3t cos 2 plus L of cos 3t sin 2. And now you can write the constant term outside. So this is cos 2 is a constant and only t function transforms. So this second term also sin 2 is constant and only t function cos 3t transform. And whose answers we know? What do you write for sin 3t Laplace transform?
S upon, no, sorry, 3 upon S square plus 9.
Yes, 3 upon s square plus 3. And second term sin 2 cos 3t transform is s upon
S upon S square plus 9.
Yes, very good. So that is your function of S, which is a transformed result. Okay, followed. So this way, just simplify by the basic definition. Always you put f of t function there. Simplify the integral. So integration, of course, you should know what is the method to be applied. And then we will get the final answer after simplifying, putting the limits and everything. We will get the answer in terms of S. Okay, and therefore, so these results are listed. So around 7 to 8 formulae are there, basic formulae, and based on that, properties are also defined. And we are finding out the answers for the Laplace transform examples with the help of that. So this is the first part where we are going to learn the basic functions transformation. In the second part, we will be doing the inverse Laplace transform. Means whatever the answer we are getting in terms of S, that will be taken reverse way to get the original function f of t. And together we are going to solve the differential equations. Okay, so I'll just share that PDF again where the formulae are written and the examples based on that are solved. So one or two again I will be showing. Yes. So coming to the same form again, so Laplace transform for the standard functions which are written here. So the first three already I have shown you. This is second one. The third one is sine function. Fourth one is for cosine function. Up to this, okay, I have shown you how the results are coming with the help of integration formula and putting the limits. Okay, Result number 5, 5, 6, and 7, please write down for the hyperbolic function. This is a hyperbolic function, sine hyperbolic 80, and 6 is a cos hyperbolic 80 function. And those functions are written in the exponential form and simplified. So sine hyperbolic function is giving the transformed answer as a upon s square minus a square, that you do it as the homework, just verify the answer. Similarly, cos hyperbolic function is giving s upon s square minus a square for s greater than mod a. Okay, so both the functions, hyperbolic functions, are converted into the exponential form like this, and then using the exponential function integration, that is only done. Okay, the seventh result, which is here shown for the algebraic function. Okay, what is your algebraic function? So algebraic function is t raised to n. For t raised to n, let us find out what is the transformed answer. So by definition, again, e raised to minus st t raised to n dt we are getting. So here one substitution you have to remember, that is st is equal to y, just to prove. Okay, and therefore s into dt, differentiate both sides. Right hand side y ka differentiation dy will come out with the form. This is a standard tool of integration. Some of you must be knowing what is that. Do you know what is this? N plus 1 is written in one standard form. What is that form? Anybody knows? What is this? What is that called? No idea? This notation. Huh? Yes. कुछ याद है?
Search.
It is called as gamma function.
Yeah.
Gamma, this notation जो है, which is looking like a root, but this is not a root, just a corner you have to draw. Gamma n is equal to, this is definition, 0 to infinity, e raised to minus x, x raised to n minus 1 dx. And if you substitute this one, st is equal to y, in the integral, this will be converting into this gamma function form, which is gamma n plus 1 upon s raised to n plus 1. So this you have to write down, gamma n plus 1 upon s raised to n plus 1. S is greater than 0 and n is greater than minus 1. And in the gamma function, actually these are the tools of integration, beta gamma functions, then differentiation under the integral sign, then reduction formulae, as well as error functions. So if you have come across this thing, these are the tools of integration. Key, whenever the integration is not possible from any standard method, we are taking the help of these tools. Okay, so in that case, this gamma function is helping us to get the answer, and one answer is very standard one in the gamma function, which you have to just write down at present, that is gamma of n plus 1 gamma of n plus 1 is equal to n factorial. Factorial notation you know, for n as a positive integer. If this is a positive integer, then you can put gamma n plus 1 as n factorial. So that is written here in the next step. If n is the positive integer, then you can replace that n factorial upon s raised to n plus 1. And few more properties of the gamma function, of course, we are using in the actual solving the examples also. So that can be considered. In at present, only write down these two terms, gamma n plus 1 upon s raised to n plus 1, when Laplace transform of t raised to n is to be calculated. Okay, For example, suppose if I take if I want Laplace transform of say t raised to 5. So I can write down this answer directly as gamma of, what do you write? N is 5. So answer is gamma of n plus 1 upon s raised to n plus 1. Formula is this one. Laplace of t raised to n is gamma n plus 1 upon s raised to n plus 1. So in this case, gamma 6 upon s raised to 6. And what do you write gamma 6 as a factorial notation, because 6 is a integer, positive integer. So what can I
And
write?
screen is not visible.
Sorry. Just wait. You see? Now it's okay.
Yes, ma'am. Now it is visible.
So tell me what is gamma 6, what I can write? What do you write for gamma 6? In the factorial.
5 factorial. 5
Yes.
factorial.
5 factorial upon s raised to 6. And how do you write 5 factorial answer? That is 5 into 4 into 3 into 2 into 1. I hope this factorial notation meaning you know. Till 1 upon s raised to 6. So whatever is the calculation of the numerator, just put it there. And denominator is s raised to 6. Okay. Got it? This answer. Now, if I take, suppose, another example, Laplace transform, say suppose t raised to 3 by 2 if I want. So n is equal to 3 by 2, which is not an integer. Correct? So we cannot apply this factorial notation here. So answer is, of course, gamma of n plus 1, that is 3 by 2 plus 1 upon s raised to 3 by 2 plus 1. What is 3 by 2? 3 by 2 plus 1 is how much 3 by 2 plus 1 means?
5 by 2.
5 by 2 upon s raised to 5 by 2. Correct? So 5 by 2, of course, you cannot write it in the factorial notation because it's a fraction. So here we are using another property of the gamma function, that is gamma of n plus 1 can be written as n into gamma n. This is called as a reduction formula for the gamma function. This is called reduction formula for gamma function. Okay, and when you write n into gamma n, you should know the answer for this also. So again, gamma of n can be written as n minus 1 into gamma n minus 1. Is it correct? Are you following or not? This is n plus 1 when it is there. 1 is subtracted and written as n gamma n. Okay. So I want the answer for gamma n. Means again 1 should be subtracted from that. And you can write down. So gamma n answer I can put it as n minus 1 into gamma n minus 1. Again, gamma n minus 1 can be put as n into n minus 1 into n minus 2 gamma n minus 2. Are you following?
Yes, ma'am.
And like that. Okay. And there is one term in the gamma notation which is a fixed value. So gamma half is written as root pi. That is a calculation from the double integration. So at present, you can just write down this as a standard result. Gamma half is root pi. So this gamma 5 by 2 we want answer here. So gamma 5 by 2 can be written as 3 by 2 plus 1, of course. And that is written as 3 by 2 into gamma 3 by 2. एक कम करो 3 by 2 में 5 by 2 से. So it can be written as 3 by 2 gamma 3 by 2. Again gamma 3 by 2 how it is written? फिर से एक कम करके 3 by 2 से एक कम किया तो what happens? This 3 by 2 as it is. This I am writing as it is into 3 by 2 say 1 if you subtract then what happens?
1 by 2.
1 by 2. So it becomes 1 by 2 into gamma 1 by 2. आ रहा है समझ में? And since we know the answer for gamma half is equal to root pi, so our final value is 3 upon 4 into root pi. So when there is a fraction, you can apply the reduction formula for the gamma function, which is of this form, n gamma n. Means every time from that gamma expression, एक subtract karo till you get the answer as half. So that is actually the meaning. So here we have, we want the answer for gamma 5 by 2. So 5 by 2 say 1 subtracted, we'll get 3 by 2, then 1 by 2, and then gamma half. So directly you can write down this step, 3 by 2 half and gamma half. Okay. Similarly, you tell me quickly what is the answer for gamma 7 by 2. कहाँ से start करोगे? Suppose it is asked for gamma.
आम्हाला 7 weeks म्हणजे 14
Shraddha madam and Utkarsha madam. Shraddha madam, please mute yourself. Okay, tell me what is the answer for 7 by 2 gamma? कहाँ से start करोगे?
15 by
5
8
by 2.
into root pi. 5 by 2 into 3 by 2 into
Correct, correct, correct. So
1
7
by 2 root pi.
Yes, so 5 by 2, 3 by 2, 1 by 2 into gamma half. And that gamma half is root pi. That's it.
15 by 8 root pi.
Yes, correct. So you understood, I think. This is the value for this one. So whenever you are getting the term in the gamma notation as a fraction containing denominator 2, not otherwise, okay? Because we know only for gamma half ka answer. So if you get 1 by 3 gamma or 1 by 4 gamma, that cannot be evaluated. Only for the half expression, means when the denominator is 2, then only we can apply this standard result and get the expression. Okay, so this is how.
Ma'am, if we'll come across the term like gamma 3 by 4, then what should be the answer then?
That is what I am telling. If gamma 3 by 4 is there, then that cannot be solved till your finite number. It will be kept as it is, 3 by 4. Now in that case, instead of gamma notation, we can think of any other method of integration can be applied. Following? Okay. So you may not get anytime 3 by 4 gamma expression because we have to keep it as it is. We can't find out its answer. So in that case, we have to use the another searching for the tool of integration and then get the result for this thing. So okay. In general, therefore, these formulae are listed along with these 7 basic functions which are given in the formulae list. And based on that, we have solved the examples. So I'll show you the examples which are shown, which are solved it here. And on the similar type, you can solve on your own by using this basic formulae, that is the basic standard functions. Okay, so standard function results we can have here yes. So this table is given here for the standard functions. First function is 1, whose transform is 1 upon s. E raised to at transform is 1 upon s minus a. Sin at transform is a upon a square plus a square. Cos at का आंसर है s upon s square plus a square. Sin hyperbolic is a upon a square minus a square. Cos hyperbolic is s upon a square minus a square. And lastly, t raised to n का आंसर है gamma n plus 1 upon s raised to n plus 1 or n factorial upon s raised to n plus 1. Okay. So these are the few expressions which are solved it here. First one, now using that linearity property, there are three functions, 5t, then 7 e raised to minus 6t and plus t raised to 5 by 2. So तीनों को separate करो to get the Laplace transform of these three functions. So first function 5 is constant, you can keep it outside, and only a transform of t. Okay, first function में Laplace transform 5 into Laplace transform t is required. Second function Laplace transform e raised to minus 6t, for which you have the standard result. And third function t raised to 5 by 2. So that also comes under the category of algebraic function. So whose transform answer you know. So first term t means t raised to 1. So you are applying the seventh result, t raised to n wala. Laplace transform t raised to n is gamma n plus 1 upon s raised to n plus 1 or n factorial upon s raised to n plus 1. So here, since 1 is your integer in the first term, t raised to 1. So n equal to 1 is your integer. So we have written this as a 1 factorial upon s square, means n plus 1 is 1 plus 1, that is 2. Second term e raised to minus 6t, whose transformed answer is 1 upon s minus a. A is minus 6, so we will be getting 1 upon s plus 6. And the third term is a fraction, just now whatever we have done, gamma 5 by 2 plus 1 divided by s raised to 5 by 2 plus 1, which is written as 5 by 2, 3 by 2, 1 by 2 and gamma half upon s raised to 7 by 2. And that is simplified. So final answer is a function of s, which we are getting it into this form. Any doubt regarding the first example? Yes? Following or still something required? Please tell me. Have you followed the first example?
Yes, madam.
Yes. So likewise, the simple calculations for 2, 3 functions combined. So second result is for again 4 functions. First is exponential, second is algebraic, third is sine, fourth is cosine function. So separated them, and for each one we are applying the Laplace transform with the standard basic function form. So we'll be getting the final answer as a function of s. Okay. These examples, even though it is there in the notes, you try on your own so that you will come to know whether you are understood or not, how the application of the formula will come here. Now this third expression is little bit different. So f of t is given here as t in the range 0 to 4, and another value of the function is 5 in t greater than 4. Okay, so there are actually two values of the function. This is your t-axis, this is 0 and this is f of t. So in 0 to 4, okay, somewhere here I can take this 4 and then 4 towards infinity. there is a value of the function. So between 0 to 4, the functional value is equal to t. So actually t means this is a graph, this way you're a straight line graph passing through the origin. Okay, you are not bothered about what exactly the graph and this thing is, just for your understanding I'm telling. The graph of 0 to 4 may answer is t, means your straight line graph is there. And then further for t towards this infinity, 4 to infinity, the answer is a 5. So somewhere on this y-axis, means f of t axis, there is the value 5, which you can have continuously existing for the rest of the values of this t greater than 4. So from here, this is a straight line. In this, so at 4, there is a break. That is why it is called as a piecewise continuous function. Okay, so you can have extension for this line up to this 5 also. This will be like a graph of this function. For that, we have to find out the transformation. So how this f of t function transforms into fs function. So for that, we will take the basic definition, because standard formula directly we can't apply. We have to use the basic definition, 0 to infinity integral e raised to minus st f of t dt. And this 0 to infinity interval, now you split it into two parts, 0 to 4 first part, and then 4 to infinity second part. Are you following?
Yes, madam.
Okay. So now in the respective intervals, whatever the value of the function, put it. So in 0 to 4, the value of the function is t. So your first integral is actually 0 to 4 e raised to minus st into t dt. Plus second integral, the answer is 5. That 5 is coming out 4 to infinity e raised to minus st dt. Second integral will be like this. Okay, and that is to be solved by actual integration now. So first integration by parts we have to go. This particular term we can integrate by parts, and second term is directly the integration of e raised to minus st. So I'll go to this pad and I'll show you. This is 0 to 4 mid t function is given. See, we want Laplace transform f of t, where f of t is defined with the value t and another value is 5 for t lying between t is between 0 to 4 and then greater than 4. Okay, so we are using the transform definition. By definition, Laplace transform f of t means 0 to infinity.
Ma'am, we cannot see the screen.
Oh, sorry.
Screen is not visible now.
Yes, hold on. You can see no. So by definition, e raised to minus st into f of t. And f of t has got two values. Between 0 to 4, the answer of the function is t. And 4 to infinity, the answer of the function is 5. Okay. And therefore, this becomes. Now the first integral is to be solved because we can't apply direct results since it is not of any basic function Laplace transformation, because your limits are different. Okay, so you cannot apply direct result for the transformation, but you have to solve the integral. So first integration by parts we will apply here. So integrate by parts in the first term. By parts कब use करते हैं? When there is a product function, product of two functions. So one of the function is t, another function is e raised to minus st. So one is u and this is v. Integration by parts procedure is this. U v dx, suppose it is to be calculated. Then first function, integral of the second function, minus under the integral sign, this integration and differentiation of the first function, du by dx with respect to x. This is a formula for the integration by parts procedure. The integration by parts will be used when there is a product of 2, 3 functions. So here this is a product of t and e raised to minus st. Now question also is there, which function you will keep it as u and which is your v function. So choice is very, very important, and that choice is taken through this LIATE form, if you remember. Log, inverse, algebraic, trigonometric, and exponential. So these are the kinds of the functions for which we are using, which is a combination given here. So here the combination is u and v. This is algebraic. This is algebraic function, and here it is exponential function. E raised to minus st is exponential. So algebraic and exponential, may which function will come first by this rule?
Algebraic.
Algebraic will come first. So here t will come first and e raised to minus st will be the second function. Okay. So integrating by parts, u is equal to t and v is equal to e raised to minus st. Therefore, first term becomes t as it is integral of e raised to minus st dt minus under the integration this integral e raised to minus st dt as it is differentiation of t with respect to t, and further we are integrating with respect to t. Okay, so this dt by dt is of course giving the answer as 1. dt by dt means 1, and this integration ka answer, and further of course you are going to put the limits 0 to 4 here. This answer is also 0 to 4. Finally we are substituting in both. Okay, it's like that. So this is t into bracket e raised to minus st ka integration e raised to minus st upon minus s by the rule e raised to ax, the formula which I have written, in the limits 0 to 4 minus 0 to 4 integral, whatever the answer you got it here, that you put it e raised to minus st upon minus s. And this, so you have got it wrong. Integration is with respect to t. So you will be getting first term. Now if you put the upper limit 4, this is 4 into bracket e raised to minus 4s upon minus s, upper limit answer. Lower limit answer will be 0 because t is there. When you put t equal to 0, you will be getting 0. Okay, first bracket. Minus, now this minus and minus will make it positive. Okay, then integration of 0 to 4 e raised to minus st. So once again e raised to minus st ka integration, that becomes e raised to minus st upon minus s, and pehla minus s, so as it is I am writing. In that again you are putting the limits 0 to 4. Correct? This is only for first term we are solving. Okay, I will call this term, this two integral terms, as equation number 1, and only the first term we are solving. So therefore first term becomes 4 into e raised to minus 4s upon minus s, and from here if you put the limit plus e raised to minus 4s upon s square, and if you put the lower limit ka negative sign, 1 upon s square, because e raised to 0 is 1. Got it? So that is the value for the integral t into e raised to minus st dt in the limits is 0 to 4. And therefore, from 1 and 2, total integral is Laplace transform of f of t is equal to, first integral का आंसर लिखो, 4 into e raised to minus 4s upon minus s plus e raised to minus 4s upon s square minus 1 upon s square, and second integral is to be solved, ये वाला, plus integral 4 to infinity e raised to minus st into 5 dt. That means first 3 terms as it is. Okay. Last term 5 will be constant. Take it outside. Take the integration of e raised to minus st, which is e raised to minus st upon minus s in the limits of 4 to infinity. Therefore, first 3 terms as it is, minus 5 upon s, I'll take it. Upper limit is infinity e raised to minus infinity minus e raised to minus 4s. E raised to minus infinity is again 0. So you will be getting only the last term, and therefore last term including the first 3. So 4 into e raised to minus 4s upon s. Second term is e raised to minus 4s upon s square upon s square minus 1 upon s square, and the last term minus 5 upon s into minus e raised to minus 4s. So all together, this 5 e raised to minus 4s upon s and 4 e raised to e, and this last term we can club. Correct? 5 plus 4. So 9 e raised to minus 4s upon s plus e raised to minus 4s upon s square minus 1 upon s square. That's the value of the transform. So answer f of s answer is this one. Yes, any
Please
problem?
show previous, ma'am, please show previous step
Which one?
from
One?
1 and 2. Huh. Yes, from 1 and 2 after that. Yes, ma'am.
Done?
Yes, ma'am.
Yeah. So I think at least today you come to know how to use the transform basic definition for the standard function. Then using the integration. Yes.
I have one
Ma'am,
doubt.
please show starting, please show, ma'am.
This example.
I think should be 4 e raised to minus 4s up divided by minus s.
I have taken it minus s only, no?
Then in the last calculation, it will be only e raised to minus 4s
Oh,
here.
okay, okay. I have
Yeah.
written it only. So here I think this
Yes.
is minus s.
Yeah.
Then it makes difference. This is minus and here we are getting positive, no? So one only is
Yes.
remaining.
Yeah.
Not like. So only e raised to minus 4 is. Good. You told me.
Yes.
So this is a correction. 9 is not there. Addition will be 1. E raised to minus 4s upon s plus e raised to minus 4s upon s square. So along with integration formulae, calculations are also very, very important till you get the last answer correctly. That is required in all these transformation problems. Okay, so okay, so this is there in this PDF which is already loaded in Google Classroom. So this example we have seen. Likewise, the other expressions are given. Question A, example number 4, sine square 4t plus 2 raised to 3t. Okay, which is calculated from the trigonometric formula. Sine square theta formula is first of all used, and then for separating them we have used a Laplace transformation. And 2 raised to 3t, like in the previous case I have given you 2 raised to t ka answer, the same thing. It is expressed in the exponential form, e raised to 3t log 2, and then simplified by standard results as such. Okay. So likewise, this is examples which are given here, transformed. These are the solved examples which you can just see for your reference. Okay, all these three, and some exercise problems which are there because the properties we have not done. Based on the properties, we have to solve the examples. Okay, so questions for the exercise you can consider like this. You can take the transform of 2 e raised to 3t plus 3 e raised to minus 2t. Then you can take the transform. Third example, you can take it. Similarly, transform of t square minus 3t plus 5, t raised to 4 plus 5, t raised to 3 plus t raised to half, and like that. Okay, these many are sufficient to make use of the standard results. And in the next lecture, so Saturday, we'll see the properties of the transform, and using the properties, a few examples are solved, and then further the inverse Laplace transformation. Okay, so as far as possible, Saturday I'll try to cover this part, Laplace transformation. If not, then next week one more lecture is required for this thing, and then we'll go for the Fourier transformation. Okay, but mainly you should be able to solve the examples in your branch with the help of Laplace transformation. That is the main concept. So for that, basic definition should be clear, and of course the integration formula in every case. So at least if you do it, so some confidence can be built, and further it will be easy for you to grasp the things if your integration is okay. Okay, shall we conclude here? You will solve the examples. These are examples jitne possible hai utne karo, but at the same day, like today, we have covered this part in this session. So if it is possible today, at least some 1 or 2 examples, do it on your own. Then it will be easy to understand the next lecture also. Okay. So on Saturday.
Ma'am, is it from H.K. Das book?
Yes, yes. This is, I think, H.K. Das wala hai ya Grewal ka hai shayad. Grewal
Okay.
maybe. Huh?
Okay,
HK
ma'am.
Das book, I think I have attached no in the WhatsApp group.
Yes, ma'am. You have shared it on WhatsApp.
So
Yes,
in
ma'am.
HK Das book, many things are given. You can refer to
Yes,
that.
ma'am.
Hmm?
Okay.
That is
And this
possible.
one is from Grewal, na?
This is from Grewal, I think. But
Okay. Okay, ma'am.
many problems are given with different variety. Of course,
Okay.
all you need not have to do, because that much time also you do not have, and so
Yes,
many
ma'am.
integration methods also at present you are not familiar with that. Okay,
Yes,
so
ma'am.
as
Okay.
our purpose should be solved, that is the only thing. You should be able to solve the differential equation with the help of transform. That is the main thing.
Yes.
In
Yes,
this
ma'am.
regard, I am teaching this particular term.
Yes, ma'am.
Yes. So we will close this meeting today, and Saturday we will meet again at 3:45. Chalega na?
Ha, ma'am.
Yes. Okay. So we'll
Okay, ma'am.
continue next time. Just wait for a minute. I'll take the attendance.
Ma'am, do we have to enter it?
What?
Our attendance, do we have to write in the chat box?
No. I'll take. Just wait for a
Madam,
minute.
also please upload today's video.
Oh, yes. That I'll do.
Yeah.
I think the previous Z transformation videos
Yes,
already.
previous we have got. Yes,
Yes, ma'am.
previous
We
we
have
have got.
got it.
Yes. Okay. Can anybody tell me how many are there actually? Number?
Ma'am, I am logging off from one device because the screen was not good on the other device. So I will log off from one device.
36
Madam, I can
participant.
36 we can see.
Maybe I can see here 36, including my 2. So in the
Yeah.
meeting, actually 34 are there. But in your regular other subject lectures, how many are there entries?
For publication ethics, we are 84 because it is including management. And research
The Google
methodology.
Classroom.
RM ला yes RM ला कमी असतात ना मॅडम 34
RP
40
ला सगळ्यात
असतात.
जास्त आहे. RP ला सगळ्यात जास्त आहे. ते कॉमन
हा
घेतलंय ना
RP ला सगळ्यात जास्त आहे. RM ला साधारण अशीच रेंज असते. हा.
एवढेच आहे.
नाही ठीक आहे, पण ते गुगल क्लासरूम मध्ये मी 33 काहीतरी दिसत आहेत मला जॉईन झालेले. त्यामुळे म्हटलं किती आहेत टोटल, त्यातले सगळे झालेत का नाही हे कळत नाहीये मला. तर I'll get of course the data from Rashmi madam. Don't worry for that. But तरी मला असं वाटलं काहीतरी 60-70 आहेत आणि half of that only I can see. Then it is the time
Yes,
to असं नसेल तर ठीक आहे, म्हणजे मग बघूयात आपण. Okay, then we'll see you next Saturday, this Saturday. Okay.
Thank you, madam.
Okay.
Thank you, ma'am.
Thank you, madam. Thank you, madam.